So today's concept is what is the first concept is granularity. Okay, so granularity is very important topic, very simple and small concept. Okay, so granularity is nothing but what is the grain of a table. So this is one of the very important question in interview. Also, this is one of the very important concept in real time when we are going to work in any data warehouse projects. Okay, so the concept is very simple. What is the grain of a tap? Grain of what is granularity or what is the grain of a table is nothing but so whenever we are creating a fact table with most granular data possible to support analysis of the business. So in data warehouse, the grain is refers to the level of details available in the given fact table. Okay, that means whenever we see any fact table, at what max level that we are going to store the data. Okay, so whenever, for example, whenever we have a fact table in real time, let's say, so this is one fact table. So this fact table is having the data at promo level. Like, so when we have the data at lowest grain, so that it will be easy for us to sum up to the different grains. Okay, meaning, let's say we have a table. Okay, so in that table where we are going to store the sales data. Okay, where we are going to store sales data. Let's say if you are going to store the data, if you are going to store the data at level. Okay, so let's say we have a product. We have a product. So this product will be purchased across different locations by the different customers, right? Right or wrong? Whenever we have a product that we are going to sell in the market, so this product will be purchased by different people, or sorry, different customers across the different regions. And the same product that we are going to sell through different stores of different locations at different times, right?
Yes, Bhaskar.
Okay, so let's say we have a we have a laptop. Okay, laptop is a product. Okay, so this laptop is produced at one location. Okay, and this will be sent to different stores, and this laptop will be purchased by different customers, and the same laptop will be purchased by different time intervals. Right now, when we have the data at the time level, store level, customer level, okay, so then it will be easy to identify if you have the data at, for example, time, customer and time. Okay, so then it will be easy to identify at the store level. Okay, if you have the data at store level, so is it possible to calculate or is it possible to get that at the customer level? Because we have the data at the store level only. So in this particular store, so this this laptops can be sold by different regions, different countries, different cities, different towns, different stores in the same town. But this one customer can purchase more products from the same store. One customer can purchase more products from the same store. But if you just store in this particular store, this many products sold. In this particular store, this many units sold. Then how will we identify at the customer level? Instead, if you have the data at the customer level, if you have the data, if you are going to store the data at the customer level, then it will be easy for us to identify at store level, because every customer is going to purchase the product in a store. So when we have the data at the customer level, meaning so customer, store, time, product. So this complete hierarchy that we are going to follow. Okay, whenever we are going to make an insert, okay, so when we are entering with this customer purchased this product on the store at this time. Okay, so this entire information that can be stored in the database. If at all only at the store level, if you are going to insert, or if at all we are going to store at, if at all we are going to load at the region level. Let's say this particular store is located in Bangalore, so that so in Bangalore this product is purchased. Then how will we identify that in this particular store how many products sold or how many units sold? So it will be very difficult. So that means what is the lowest level of data that we are going to store in the database or in the fact table is what we are going to call it as grain of a table. Understood? In a simple way, in a technical way, if you wanted to sell, on which all the column combination where we are getting the unique data is called as grain of a table. This is a technical term. On which all column combination where we are getting the unique data. Whenever we are going to write a duplicate query, select columns counts are from table, group by column having counts are greater than 1. So which are the columns that we are going to specify in the group by class, which is going to give the null value. Meaning there should not be any duplicates on certain column level. So on which columns and which we don't have any duplicate values is what the grain of a table. That we will call it as technical term. Okay, at the functional level or data warehouse level, we should say what is the lowest level of data that we are going to store in the fact table is what? The grain of a table or granularity of the table.
It means, Bhaskar, this is the composite key, right?
Yes, this is the composite keys.
This
Yes.
is the composite key. Well, to making the composite key is the granular thing.
On which column combination?
Yes, yes.
Okay, so on which, let's say there are certain situations where if you see right, we have facts, different type of facts. So whatever the calculated value that we are going to give it here, so this will be of these three types: additive fact or semi-additive or non-additive. Okay, when we wanted to generate this calculated field based on all the column combinations, based on all the column combinations, then we will call it as additive fact. Okay, there are certain situations where we are going to store, where we are going to calculate only certain levels, certain column. Let's say for every store, this register promo are same, for example. Okay, so that we don't need to use this register and promo in the group by class. If our clerk also same, let's say we can use only time, product, store, and customer. In this particular store, this product is purchased by this customer at this time. That's it. If you're going to use only these certain columns in the group by class in order to generate this particular fact, in order to generate this particular fact, this is what we will call it as semi-additive fact. Sometimes we are going to get the data, this calculated values directly from the business. So even though we have the composite key or even though we have all the key columns in the fact table, still we will not be having, we are not going to do these calculations. Okay, we are not going to do these calculations. So that we will call it as non-additive fact because we are not summing up any data using these key column combinations. Okay, for every factorial in real time, if you see, there will be keys of dimension tables and there should be a calculated columns. All we have to understand is, so even this fact table where we will be having a source table. Okay, from source, which all the columns are coming and what is the key columns are present. In order to get this key column, what is our dimension table? So in this dimension table, what is the key column? Key in the sense, what is the natural key column in the sense on which column combination where we are getting the unique data. Okay, what is the grain of this dimension table? Okay, what is the, so let's say in product dimension where we will be having product name, for example. Product name is unique identifier. So for every dimension table that we are going to load to the fact, first we should identify what is the unique identifier in the dimension table. Or before we load the fact table, first we will load the dimension table. when we are going to load the dimension table from a source table, we need to identify on which all column combinations where we are getting the unique values. So that column combination we have to use in the join condition in order to identify the records coming from source are already exist or not. Okay, similarly, on which all column combinations that we see it is a unique data. So for fact table also there will be a source. From that source, are we getting these columns or not? Let's say we have here product name and brand. These are the two columns as unique identifier. Okay, without brand there are several products. Without product there are several brands. But if we do the combination of brand and product, we have a unique identifier. Okay, we need to see from source also we should get these two columns. Then only we can do a join with this product table to get the product. If at all we are going to have only the product name from source, but we have a combination is product and brand here, then we'll be getting duplicate data because one product name with different brands are possible. So that is the reason product and brand are the unique identifier. So whatever the table that we are going to load from source, either be it a dimension table or be it a fact table. So what is the source and what is the key column, natural key identifiers? Okay, so those natural keys should give the unique data. Based on that natural keys only, we are going to do a join. So grain of a table or granularity of a table is nothing but on which are the column combination where we are getting the unique data. So that we will call it as grain of a table. Understood? See, in real time, so this is just kind of a functional knowledge for all whoever wanted to learn. Okay, in real time for your work, when you work as a developer, so all you wanted to know is, so the moment when we say what is the grain of a table, so you should remember that what is on which are column combination where we are getting unique data. Yes, this is the grain of a table. That's it. Concept is simple. But there are few people they wanted to understand the functionality. They wanted to see what kind of data that I'm getting and what is the purpose of this data. Okay, so for them, so this is the concept which I explained. Any questions? Anyone having any questions? Others? So,
Ya Bhaskar, no Bhaskar.
Nirisha.
No, Bhaskar.
So then the next concept is there are different type of dimensions. So whenever we say this is a dimension table, okay, whenever they say this is a dimension table, what kind of logic that we are going to store? Okay, the moment. So in real time, people will not say that. So this is a conformed dimension. There are different type of dimensions. Conformed dimensions, junk dimension, degenerated dimension, slowly changing dimensions. Okay, so in real time, people are not going to tell that do this logic, do that logic. Okay, so we need to ask, or they will tell us this is a conformed dimension. Okay, so we should understand what is conformed dimension, or we should know what is confound dimension. Confound dimension is nothing but, so in a data model, we are going to work in a data model if it is a data warehouse project. Okay, so in a data model, whenever we build any dimension table at once, and we'll be reusing the same dimension table in multiple places of the fact tables. So for every dimension table, sorry, for every data model where we'll be having multiple fact tables, several fact tables will be there. And whatever the dimension that we are going to create, and that dimension is going to be used for many of the fact tables. That we will call it as conformed dimension. For example, we have a date dimension or time dimension. If you see this time dimension, so days of the week, period of the week, okay, month of the week, month of the year. So there are certain date related fields will be there. First day of the month, last day of the month. Okay, for example, for every date, so what is the first day of the month, last day of the month? For every quarter, first day of the quarter, last day of the quarter. So these kind of date related values will be placed in time dimension. So this time dimension will be used for every fact table across all the fact tables in the data model. Or we have a product dimension. So this product dimension, so for every organization is going to sell a product, right? Every organization, they're going to sell a product. So when they are selling a product, this product dimension is common across all the fact tables. So these kind of dimension, time dimension or product dimension, these kind of a dimensions which are going to be built once and will be reused across all the fact tables in the dimension model. So that kind of a tables, we'll call it as conform dimensions. So the next dimension is a junk dimension. So junk dimension is nothing but a collection of random transactional codes. Let's say simple example is share market. So whenever we see share market, right? So for every second, every millisecond, like the values will be keep changing. The stocks will be keep changing, right? So when for every minute or every second, the stock will be keep changing. But each and every transaction is very, very important. But in order to identify, so at what point today's Sensex is started, and what is the lowest point, and what is the peak point, what is the end point. So when we are going to identify these points, okay, what is the profit today, what is the loss today, we are going to consider very few records, very few transactions. But still, we are going to load all the data because at what interval time that we wanted, that we don't know. But we are going to store across all the records into the all the transactions into the dimension table. Okay, this is just a transaction. On top of it, we are going to generate profit, loss, start point, end point, all these things that we are going to generate. Okay, so storage of random transactional data is called as a junk dimension. Okay, so that means there will be huge data will be get loaded, but we are going to take very few records for our calculation purposes. That we will call it as junk dimension. Next is degenerated dimension. Okay, degenerated dimension. In a fact table, there are certain dimensional attributes. Okay, so those dimensional attributes will dimensional attribute in the sense there are few dimensions. So that dimension, one second, someone is speaking. Okay, so there are certain dimension that will be used for only one fact table, and that dimension table is having only 2-3 columns. Okay, so a dimension table is having only 2-3 columns, and that is being used for only one fact table. So instead of creating a separate fact table, what we do is we'll create a single. Sorry, we'll be using these 2-3 columns in the fact table itself. That we will call it as a degenerated dimension. If at all we see any dimension attribute in a fact table, usually for every dimension attributes, we are going to have a separate table. But instead of having a key column of a dimension, if we are going to store the direct dimension attribute in a fact table, we'll call it as degenerated dimension. A dimension which is located in a fact table known as degenerated dimension. Okay. Any questions in this? What is junk? What is confirmed? And what is degenerated dimension before I go to slowly changing dimensions? Tell me, anyone having any questions?
No, Bhaskar.
No, Bhaskar.
Okay. The next is slowly changing dimensions. So this is very important concept that we are going to use every day in our day-to-day life. Okay. There are the slowly changing dimensions is nothing but the information in the dimension table is going to be changed slowly. Okay. So there are three different type of slowly changing dimensions in the data warehouse. Okay. SCD, slowly changing dimension, type 1, type 2, and type 3. Type 1 is nothing but whenever we say type 1 slowly changing dimension, type 1, this dimension table is a slowly changing dimension. Okay, that means type 1 dimension, meaning always this dimension table is going to store the latest data. Okay, always it is going to store only the latest data. Let's say there is a customer, let's say there is an employee, so who joined in the organization. So when that employee joined in the organization, so there will be one entry in the source table. So we use ISCS or Informatica to load this record into the target table. Okay, and if the employee moved from one location to a different location, let's say employee joined in Bangalore location and the same employee moved to Hyderabad location. Okay, when is moving to Hyderabad location, so there will be an update in the source table stating that this employee, not update, there will be one more record inserted to the source table stating that this employee moved from this location to this location. Now when we are executing our ISCS, we are going to update the existing record, meaning we are going to store only the latest information of the employee in which this employee is currently located. Okay, so what we are going to do, whatever the record which is coming from source, we will be checking on the target table whether this particular record exists or not. If employee does not exist, we will be making an insert. If employees exist and if there is any change, then we are going to update. So
That old
we are
record,
going to,
that old
sorry?
record which is being inserted, that will be moved to deactivated, right?
No, we will not deactivate that. We will be keep updating that. If at all that dimension says that it is a SLA type 1 dimension, we'll be keep updating the existing records.
Okay.
So that we are going to store only the latest information in slowly changing dimensions type 1. And slowly changing dimensions type 2. Type 2 dimension where we are going to maintain the history. Okay, the point what you just told. We are going to deactivate the previous record and insert the new record. So that we are going to maintain a complete history about this particular record. Okay, so when this employee joined in the organization, what is the start date, what is the end date, and when he moved from Bangalore location to Hyderabad. Okay, in Hyderabad location, what is the start date, what is the end date, and from Hyderabad he moved to Pune. So every change in the source table, okay, will be having start date and end date. So or we'll be having a active flag. We are going to make it inactive. Only the active record will be having Y and inactive records will be having. We are going to flag the records. Okay, we are going to flag the records. So that we are going to maintain the history. Whenever we say that SCD type 2 dimension, this particular table is a SCD type 2 dimension, meaning we are going to store current data plus historical data. How are we going to maintain the current plus historical data? There are two methods. Either we are going to use start date and end date method, or we are going to use flag method. In start date and end date method, so for the latest record, we are going to have start date as system date and end date will be some future dated value. And when any change is coming up, we are going to make it as a new insert with start date as system date, end date will be future dated, and we'll be updating previously active record or previously having future dated record end date with system date, so that when it is got started, this transaction started, when it is ended. Again, when this transaction started, when this is going to end. So the records which are having some future dated value is call it as active records. That is one way of doing it. So the other way of doing it is flag method. Like we are going to just make it as active or inactive. So whenever new transaction is coming, we are going to inactive the previously active record, and we'll make this current record as an active record. So that we are going to have all the inactive records along with the active records. Meaning current data and historical data, both we are going to maintain in slowly changing dimension type 2. Next, slowly changing dimension type 3. So here we are going to maintain partial history. In slowly changing dimension type 2, type 3, we are going to maintain partial history. Like, so what is the base location or what is the started location and what is the current location? If the employee moved from 3-4 locations, we are not going to have the complete history, but we'll be having certain history like start location, end location, or start location and current location. Like that, we'll be having some history. We are going to maintain SED type 3. So in real time, we are not going to use SED type 3 at all. In my past 12 years of experience, I never used it. Okay, but this SED type 3 is required for interview purpose. But SED type 1, SED type 2 are very, very important that we are going to use it in real time regularly.
So, Bhaskar, in the last project, means in the real scenario, okay, the type 3 is not used. Type 1 and type 2 is used, right?
Yeah, type 1 and type 2 used.
Okay.
Where in GRDC you're telling?
Yeah, GRDC and other.
GRDC it is type 1 actually, because
Okay.
we'll be having, sorry, it's not type 1, it is type 2 we have used because we have active inactive records. So active flag we had. So active flag we are just, previous record we are making inactive and current record we are making active. We are inserting every record and we are making the, if record is exist, making that record as inactive and inserting with the active record flag.
Okay. Got it.
So based on the target table structure, we can identify. So we don't need to ask anyone. So if the target table is having active flag and active flag or start date end date columns, then we can identify this is a type 2 dimension where we have to maintain the complete history. We don't have this flag column, active flag or start date end date fields, then it is a type 1 dimension which is going to have only the latest information. Okay, if at all we don't have start date end date, if we just have only the flag column, active flag column, then we need to ask, do we need to maintain the history or not? Because there are certain situations where this active flag will be coming from source itself. Okay, so in this case, we cannot consider that as a type 2 dimension. So usually all the dimension tables will be type 1 dimensions only. Dimensions tables, all the dimension tables will be type 1 dimensions only. There are very few dimensions which are with type 2 dimensions. Okay, so that is depends upon the requirement. So if business says that they wanted to track the complete history changes, then we are going to have the type 2 dimension. Otherwise, we'll be having type 1 dimension only. So mostly all the dimension tables will be type 1 dimensions only. Any question? Type 1 or 2 or 3 dimensions?
No, Bhaskar.
No, Bhaskar. Clear.
Next is staging area. So in real time, so for every project where we will be having a concept of staging area. Okay, so when we are going to read the data from different heterogeneous sources like flat files, Oracle, SQL Server, Snowflake, Postgres, any database, like the source is having the different databases. Targeted is a data warehouse. So in that case, what we will do first, we are going to get all the different sources data into a single place called staging area. Okay. So now when we are going to load the data from different sources into the staging area, so there are certain activities that we are going to do. Okay. So if at all we are getting any data cleansing activities. Cleansing activities is nothing but if at all there are any unwanted characters or special characters, okay, or any conversions, date conversions, numeric conversions, string conversions. So if at all any conversions are there, so these cleansing activities, unwanted characters will be removed, cleansing activities will be performed, and we are going to load the proper data into the staging area. Because whatever the data that we are going to load in the staging area, that data will be used to load in the dimension tables and fact tables. Okay, so staging area is the place where we are going to perform data cleansing, data merging. Data is merging nothing but different sources data that will be getting into a single place. Okay, and data scrubbing. Data scrubbing is nothing but eliminating individual pieces of the data. That means, so when somebody entering the data where customer name is not there, customer mobile number, customer mail ID, and other information. That is a junk data. Okay, so this kind of data that we will eliminate, we'll put a certain conditions. If this condition is true, then just load the data like that. Okay, so that we are going to have proper useful data into the staging area. Okay, so staging area is a place where we are going to have data cleansing, data merging, and data scrubbing activities that we do, and we are going to get the data into staging area. So then the staging area is a kind of a temporary storage. Get all the data into one place, use that to load the data into the database. Okay, so next is ODS, operational data sources. So this ODS is nothing but, so nowadays people are not using, but earlier people were using it. Okay, this is for interview purpose. Okay, so this ODS operational data source is just kind of a replica of OLTP system. Okay, because as soon as the data is going to come to the OLTP system, immediately that will be scheduled to run to a ODS layer. Because in the staging layer where we are performing this data cleansing, data merging, data scrubbing activities, but into the ODS layer we are not going to do anything. It is just kind of a replica of OLTP system. From the application database, just replicate that into a ODS layer by scheduling some Informatica jobs. So on top of it, we are going to do this cleansing and scrubbing activities to load into the staging area. Okay, so ODS is kind of a replica of OLTP system. Okay, and we are not going to perform any data cleansing or scrubbing activities on top of this data. So nowadays, see, earlier the people were designed ODS layer because when we are executing our jobs, right? So there, if the jobs are taking time, so that the front end application system also will be working on the same table. Sometimes when we are loading the data and if it is taking time, there are possibilities to log the source table. When the source table is getting logged because of this Informatica executions, then the production system will be get impacted. Production system will be get impacted. So because of that, people introduce a concept of ODS. Okay, ODS is just a dump. So since we are not performing any cleansing, right, it will not take time. So it is just a dump that they were doing it. But nowadays nobody is doing that. Okay, just for interview purpose, we have to understand this ODS layer. Then the next concept is a surrogate key. Okay, surrogate key is an unique identifier in every dimension table. So in every dimension table where we'll be having unique identifier. Okay, that's a dimension keys. So 1, 2, 3, 4, 5, 6, the unique numbers that we are going to store. Okay, so normally this is going to be a sequence generated numbers. Okay, using sequence sequence generator transformations. Okay, but only thing is, uh, for interview, the people are going to ask what is the difference between primary key and surrogate key. Primary key is a constraint. Primary key is a constraint will be defined on the database, which is going to have not null and unique values. Okay, so in case of surrogate key, uh, in case of surrogate key, what is going to happen? So this is not a real natural key. Okay, because if at all we are going to use multiple columns as a key combination, let's say as I mentioned earlier, product dimension, product and brand are the combination on which we are going to have unique identifiers, right? So that is a natural key column. Okay, the natural key is nothing but the columns which are coming from source 2. Okay, so in order to identify a unique identifier, sometimes what we are going to do is instead of using those many columns, we can use the surrogate, which is having unique identifier. But it will not come from source, it is a sequence generated number. Okay, the simple concept is primary key is a constraint which is going to be used to maintain not null and unique values. Surrogate key is a column which is going to have unique values generated using sequence generator, then can be used as instead of real natural keys or instead of primary keys. Okay, so always surrogate key will be an incremental integer number 1 2 3 4 5. But primary key can be have many columns or combination of one column or two columns or three combination or four column combination that we can use. So that is the difference between primary key and surrogate key. Okay, any questions? I go to dimension model. Any questions, anyone?
No, Bhaskar.
No, Bhaskar.
So next is dimensional model. So basically, we as a developers, we don't need this dimension model concept, but I'm going to explain this for you because when you get into real time, when people are in the initial phases of a project, people will be more discussing about the dimension models or the data models. Okay, so this data modeling, when people are explaining, at least you should have minimum knowledge about the data. Okay, so data model, actually it is kind of a big subject which is going to be used by the architects. Okay, but we as a developer, how much is required for us that we will learn. Okay, because when we will join in the meetings, so at least we should be able to understand. We should be able to understand what exactly they are discussing about. Okay, so what are the different types of data models that we have? So for every phase of a project, okay, for every phase of a project, the architects who are going to be design this model, the data model. Okay, so this dimension model will be having dimension tables and fact tables. Okay, now on based on this dimension, so on top of this dimension on fact tables or with these dimension and fact tables only, the data model will be created. Okay, so when the data model, when architect is going to start, what they are going to do, they will interact with the business people and they will be getting what kind of details that I'm getting from the application. Like am I getting customer data, sales data, countries data, source data, product data. So what kind of data that I'm getting? So that information will be taken from the business and they'll be think of to create a conceptual model. The first phase of data model is conceptual model. So in the conceptual model where we'll be having only table names. We don't have any attributes or we don't have any columns. We don't have anything. We will just have only the tables. So this is the fact table and these are the different dimension tables that we have. So this fact table can store the data of these dimensions. Simple. Concept is very simple here. So let me open Paint. Okay, concept is, so in the conceptual model, this is one fact table, this is one dimension table, this is one dimension table, this is one, and this will be linked like this. Okay, let's see, this is, so this is the customer dimension. So this is the country dimension. So this is the product dimension. This is the store dimension. So this is a sales fact. Okay, so this is just a concept. So based on the requirement from the business, what people are going to think like, sorry, what the architect will think. So this is how this I'm going to build this model. So this we will call it as a conceptual model, because I will be just knowing only the what is the fact table and what are the dimensions that I'm going to be used in this fact. So similarly, there will be other fact table and what are the other dimension tables that I'm going to use. So we like this, a conceptual model will be generated, and this conceptual model will be explained to the business. So this is how I'm building it. So any questions? Okay, any updates? Because the business people will be knowing what exact kind of a data is coming up and is it really linking like this only or not, because they will be knowing their application, how it is built. So accordingly they are going to tell us if at all any changes. So conceptual model will be having only the important entities and the relationships among them, no attributes, no primary keys, nothing. Next is a logical model. So in the logical model, where we are going to just have entities and relationships. Along with that, attributes of each entity will be specified. Attributes of each entity will be specified. What are the different entities will be having? These are different attributes. Like what are the possible columns in the customer table, possible columns in the country table, possible columns in the product table, possible columns in store, and also possible columns in the fact table. So the key, all the possible columns are going to be mentioned in the tables. Okay. So once after that, so primary keys and foreign keys. So with the primary key and foreign key only, the links will be established. Okay. So in the logical model, where we will be identifying all the entities and specify the primary keys, find out the relationships, find out the all attributes. That means column names for each entity. Okay, and resolve many-to-many relationships. So how the relationships are being established. So next is a physical model. So in the physical model, so whatever the tables in the logical model that we built, those will be physically created in the database. So in the logical model, we are specifying that this is the table, and this table will be having this primary key, and this is the foreign key. So we will be just mentioning logically. So until we complete the logical model and get it reviewed and get it confirmed or get it go ahead, we are not going to have the tables created in the database. Okay, so when it comes to physical model, so the finalized with the logical model, we are going to create those tables in the database. So whatever the entities that we created in the logical model, so that we'll be creating into tables, and the primary key constraints and foreign key relationships that will be established and whatever the attribute that we say in the data model, that we will be converting it to a column in the table. So because entity, so in a data model perspective, we are going to call it as entity. In the database perspective, we are going to call it as table. In the data model, we are going to call it as attributes. Columns will be calling as attributes. In the database, we will be calling them columns. So these are the terminologies that you have to understand when people are discussing about this data model. Okay, so when they say that entities, what is the entity? When they say that attributes, what is the attribute? What is the difference between entity and attribute? We should be very much careful about it. Okay, because we'll be knowing about the tables and columns. But if at all we have, if business says that are in the discussions, if they say that entity or attribute, we should understand, okay, in the data model world, we'll be they're calling table as entities, column as attributes. And these are the difference between logical and physical models that you can go through. Okay, any question? So with this, I can say that data warehouse concepts also completed. So any questions anyone having?
Bhaskar, in the logical data model, there's a 6 points, right? Like identify entities, primary key, and this 6 one's normalization. Like, what is that normalization?
Yeah, normalization is a very big concept actually. Even you won't even understand about the normalization.
Oh,
That's
okay,
why I purposely did not explain that. Okay, because that is actually required for a data models. Okay, we as a developers, when we are going to work, that normalization concept is not required, because normalization, there are 4-5 normalization forms are there. Okay, each normalization form is having again certain requirements. Okay, so based on this requirement, you have to use the first normalization form or second normalization form, third, fourth, fifth. So these are the kind of different normalization forms and different functionalities for each normalization form. For every kind of a requirement, we will have to for this kind of a requirement, this normalization form that we have to use. Like that, there are certain normalization forms are there. Okay, if I
this
go
is
into
used in. Sorry, this is used in data model, data modeling.
data modeler or an architect.
Okay.
So we as a developers, we'll be getting, the first thing is this data model concept is required when we are going to be in meetings of data model discussions. So at least we should be able to understand when they say that it is a logical model or a physical model, what exactly is that? When they say that this is the entity or attribute, what is that? Okay, how logical model is going to work or how physical model is going to work, and what is the conceptual model? Okay, and sometimes what business is going to tell. See, earlier how it was, how it was working is, like how we were working is, they'll be giving a data model to us. Okay, so this is a model, you prepare Informatica mappings. But nowadays people are little proactively giving the list of tables, sources, everything they are giving with the clear requirements. Okay, so usage of data model is very much reduced nowadays. Earlier we were using a lot actually the data model. So now people, right, they're not making the developers complicated. Okay, they are just directly giving the mapping documents and the with the clear requirements. Okay, this data model will be used just for a reference when we are loading the data. So how these tables are getting linked and how what the data is coming up. Okay, what is the relation between these tables? If at all we wanted to see that, we can see the data model, but I would say 70 to 80% of the developers will not see the data model. They'll just go with the requirement. What is your requirement? What is your source? What is the target? And what is the logics that I have to implement? Just tell me that, I'll load the data, do the unit testing, hand over it to you. That's it. खेल खत्म, दुकान बंद.
Okay. Only the architects or whoever is giving the requirements, they need to know like in depth on that
Yes,
so that they can create
yes.
the
They should know
relation.
about these normalization forms. What is
Okay.
1F, 2F, 3F, 4F? Okay.
Okay.
So the
Okay.
normalization form, they should know it.
Okay.
Without
Okay.
knowing the normalization forms, anybody cannot become a data modeler or an architect.
Okay. Got it, Bhaskar. Thank you.
Others? Anyone have any questions?